Imagine this. You're floating 400 kilometers above Earth. Your spacecraft has been destroyed. Your suit is damaged. And you have about 15 seconds before your body does things you really don't want it to do.
What happens next isn't like the movies. There's no dramatic explosion, no instant freeze.
What actually kills you in space is far stranger and happens in stages you can actually feel. So let's walk through it, second by second. Because understanding how space kills you might just be the key to surviving it. But first, why doesn't your blood actually boil like everyone says? Here's the thing about your body. Right now, you're being crushed by 14.7 pounds of pressure on every square inch of your skin. That's 1 atmosphere, and your body is perfectly designed for it. Your blood vessels, your lungs, your eyeballs, they're all pushing outward with the exact same force.
It's a constant tug of war, perfectly balanced. In space, there's no atmosphere, zero pressure. So that tug of war, your body just won. And that's where the problems start. Let's say your suit tears, maybe a micrometeorite, maybe equipment failure. Doesn't matter. You now have 15 seconds of useful consciousness. Here's what happens in those 15 seconds. And yes, you stay conscious long enough to feel almost all of it.
The expansion.
Your body doesn't explode. Hollywood lied, but it does swell. The moisture on your tongue, in your lungs, on your eyes, it starts to boil. Not because it's hot, because at zero pressure, water boils at room temperature. You feel your saliva bubbling. Weird, uncomfortable, not painful yet.
Second 3 to 5, the air rush.
If you held your breath, your lungs would rupture. Astronauts are trained. Exhale immediately, so your air rushes out, fast. You feel your chest deflate. You can't breathe in. There's nothing to breathe.
Your blood oxygen starts dropping, fast.
Second 8 to 12, the hallucination. Hypoxia kicks in. Your brain, starved of oxygen, starts misfiring. Colors look brighter, sounds echo. Some astronauts who've experienced near vacuum during accidents reported feeling euphoric, happy, like they're dreaming. This is your brain's last-ditch survival mode, shutting down pain receptors, conserving energy. You're dying, but you feel fine. Second 13 to 15, the shutdown. Your vision narrows, tunnel vision, then darkness. You're unconscious now. If rescue doesn't come in the next 60 to 90 seconds, permanent brain damage begins. At 2 minutes, you're dead. But here's the crazy part. This has actually happened, and someone survived. 1965, NASA's testing facility in Houston. A technician named Jim LeBlanc is testing a spacesuit in a massive vacuum chamber. A hose disconnects. The chamber depressurizes. Jim is suddenly in near total vacuum. He felt his saliva boiling on his tongue. His last conscious memory? The taste of metal and the sound of his own heartbeat slowing down. He was unconscious for 14 seconds. Engineers repressurized the chamber, and Jim LeBlanc woke up. He survived. No permanent damage. Because 15 seconds in vacuum? Survivable. If, and only if, someone gets you back to pressure fast enough. That's why every spacewalk has a buddy system, why suits have redundant life support, why space stations have airlocks with emergency protocols. Modern suits can self-seal small punctures. Space doesn't hate you. It doesn't explode you, freeze you instantly, or make you burst into flames. It just removes the one thing your body absolutely needs to function: pressure. And that's what makes it so dangerous. It's not violent. It's quiet, clinical, efficient. And every astronaut who floats outside their spacecraft isn't just exploring space. They're proving that humans can beat the odds, even when the universe says we shouldn't. Thanks for watching. Stay curious.